Okay, so this is the Millionaire calculator, and this is the first calculator to do automatic multiplication. And since I was working on this, I figured I'd make a little video going over how the mechanism actually works. Um, and yeah, I mean, there's other resources out there, like John Wolfe has a pretty good post on his website, basically taking one of these completely, totally apart, and has pictures of all the pieces and describes how everything all works together. But um, just in case anyone's interested, I thought I'd make a little video also explaining it. So before we get into anything here, I'm going to insert a clip of the video with the carriage out of the machine, just because it's a lot easier to see what's going on, because there's some parts under the carriage that you can't really see with the carriage on. So we'll cut to that, and then we'll come back and pick up from there. So this is the Millionaire Calculator Mechanism, and we're starting with it in a partially disassembled state. The reason being, I would like to show as much of the operation as I can, and once I put the carriage and stuff on, some of the parts are hidden. So yeah, that's why it's kind of like this. So I'm just going to start with a little tour first of all. So this part in the front here is the register drive. So your input sliders, which are these, normally sit right here, and then they control these sliding gears, which are attached to these square shafts. So every time this gear turns, you can see the shaft turns. So the driver of the machine drives these racks, which turns these gears, and then these bevel gears here actually drive the register, which is over here. And I'm sure you can be able to see it. If I tilt this up. On the bottom of there's bevel gears for each digit wheel. So as these turn, they in turn turn the bevel gears on the bottom of the digit wheels, and advanced them. Of course, I can't really turn it with those little nubs there, but I hope you get the idea. So these are your input slider control things here. Basically, the input sliders move these up and down to select a rack, and then these racks are driven during a machine operation by the heart of the machine, which is the hard-coded multiplier table right here. So I can put this little lever on here, maybe. Well, it should go on better than that, but anyway, you turn this to select your multiplier, and that moves the multiplier table up and down. I'm not sure why this doesn't want to go on all the way, but yeah, and then of course this multiplier table is controlled by this. This is a whole, these two pieces here. You can see they got slots in them, and the multiplier slides in those slots, and then these are moved back and forth by this crank over here. So you can see this crank has a rod that goes to a pin down there, and that pulls the whole table. So I'm going to demonstrate this all in a minute. I just kind of want to give you an overview of what's going to happen when I start operating the machine. But yeah, so basically the way that this multiplier works is essentially it's sort of the combination of this lever and your input sliders are basically selecting a pre-coded value to add to the register. So think of this multiplier table here, you got a better view on the front of it, as sort of like a 2D matrix, or kind of like a spreadsheet where you've got rows and you've got columns, and each row and column can be selected by an address that picks one cell out essentially, and that one cell has, in this case, has the value that you want to add to the register. So for example, if I move this, say, to 1, which I need to find something to hold that there, but and I move this to say 1, I've selected row 1 on the on this lever and column 1 on this slider, and that gives me basically this cell right up here in the corner. And each cell has a pair of values. So it has a tens value, which in this case is just 0, and it has a ones value, which in this case is 1. So if I select row 1 and I select column 1, that means that this particular register drive is going to add 1 in the ones place of the register. So essentially, that's multiplying 1 by 1. Similarly, if I keep this on 1 and I select the bottom row, so I move this down to here, we look at what's in that cell and we see it's a 0 and a 9. So by selecting 1 on the multiplier lever and the 9 on the input slider, I'm going to add 9 to the register, which is 1 times 9. And then if you move this down more, you start getting into the more complicated values. So for example, if I put 2 here and I leave my slider on 9, I'm not sure if you're going to be able to see, but now that cell has a 1 in the tens column and an 8. You can look at the side here. You can kind of see right there how it steps down. So that's an 8 in the ones column. So basically, by selecting 2 here and a 9 there, I'm going to add 18 to the register. And we'll demonstrate this once I get the register back on. I just kind of wanted to show basically how all these parts interact when you can actually see all of them. And if you're wondering how an 8 and a 1, combined with this rack, make up 18, that's because there's a fancy shifting, kind of see there's a screw here. So when you put it in multiply mode, it actually does the 1 first, then moves the carriage and moves the multiplier table over and does the 8. So it does 1 in here, moves the register over. So now there's now a 1 in the tens column, then adds the 8 again in the units column. So yeah, basically how these work for subtraction mode. So let me see if I can kind of show this in operation here. I would like to put this corner plate back on because this thing just kind of flops around and this thing runs into that thing when you operate it. So I'm going to do this with as minimal operations as I can before putting this cover plate on. Actually, I can probably do that pretty soon. Let me just show. So let me just give an overview of the whole thing. I think you've got the whole thing in frame there. So if I turn the crank once, what's going to happen is this shaft is going to make 1 revolution, and this thing is going to go back and forth 2 times. And notice that the first time the register or the multiplier is going to be in one position, and it's going to move over to the next position. So you see now it moved over. Now we're back in the home position. Yeah, basically all that's under this plate is this stick, which is the mode selection and the crank for this. So I don't think there's much to show here. I'm going to put that plate on and then we'll continue. Okay, so let's pop this plate back on. That holds this in place. So now when we operate it, we don't get that clanking around there. So in addition mode, there is no register shift. So basically you're essentially wasting the whole 10 digits part of the operation. Nothing happens when this is in addition mode. When we go to multiplication mode, however, and you'll watch, so this, you see the things are moving down here. So this plate is attached to this rod. So you'll see when I move my selector, this whole rod turns, and that rod is attached to this little fork down here, which has a pin that goes into this roller. So this roller essentially does 2 things. This back half of the roller, which is actually this roller and this roller, selects whether it's addition or subtraction. And then this front part of the roller, you can see it kind of has a little cutout in there, selects whether or not there is a register shift or not. So in addition mode, we've got this piece has a pin that goes inside this cam, and nothing is interacting with this, which is the register shift. If I move this now to multiplication, you'll watch, this now comes over and engages with this, I'm not sure what you call that, but basically this locking mechanism here, which locks this drum and this shaft together. So in addition mode, I'm going to turn the handle. Notice that the drum turns, but this piece stays stationary. If we go to multiplication mode, which I don't have the right screws in this plate, I just grabbed some. Watch, now the whole thing is locked together and turns. If I go to division mode, you'll watch now, this cam has engaged with this piece, and now this is not engaged at all with this cam. So now this is the subtraction cam. And basically the only difference there is it determines which direction these gears move. So when it's in addition and multiplication, notice they move forward to engage with those bevel gears on the bottom of the register. If I put this in division mode, now they're going to move backwards. And basically all that does is it turns the register wheels backwards for division and subtraction, and forwards for addition and multiplication. And how that works is this brass plate down here is what moves those wheels. And you got a pin here on this side and a pin here on that side. Those pins go into these levers here, which are attached to this shaft, and then this shaft runs all the way over to this. So the rotation of these cams, you can maybe get a better view of, rocks that shaft, and as that shaft rocks, you get the whole thing in shot. As that shaft rocks, the register wheels engage and disengage in the appropriate direction. So now I've changed it to addition mode, and I go the other direction based on the other cam. So that's how the machine determines whether it's doing an addition or a subtraction, and also how it knows whether to shift the carriage or not shift the carriage. So in multiplication mode and division mode, this drum locks to this shaft, which is attached to this screw. So you notice if I turn the crank now, you can see that part has a screw on it. So that screw is what moves the carriage. You can see it moves the carriage one position for every turn of this main crank. So that is only engaged, however, for multiplication and division mode. If I move this now to subtraction, this drum has now moved over so far that this shaft is now inside a hollow piece in this drum. So if you watch now, you can see there's a 5 on there. That 5 is not going to move when we're in subtraction mode. So essentially this main shaft, this main thing here, this drum and this drum are basically what controls the register shifting and the mode for addition and subtraction of the whole machine. So just to go over it again, you've got addition, multiplication, and multiplication is engaged with these tabs and engaged with the add cam. Division is engaged with these tabs and engaged with the subtraction cam. And then subtraction is disengaged with the tabs there and engaged with the subtraction cam. Go back to addition, and we're disengaged with the tabs and engaged with the addition cam again. So that's basically how your mode selection works for this machine. And one other thing I wanted to mention, there is a piece here that also slides, and that piece has tabs on it that lock this cam. So when this shaft is not engaged with this drum, it's being locked by this, which engages with a cutout in this disc. Actually, I can probably show that cutout. So that turns around, you can see there's a cutout right there. So when this is not engaged with this, you see this is now locked by this piece down here engaging with the cutout in that disc. So that's what keeps it positively engaged. So it's always positively engaged. It's either engaged with that that sliding piece down there in this cutout, or it's positively engaged with this drum. Okay, so I think that mostly covers the mode selection. And again, this shaft is just driven by, you can see the crank goes down to a bevel gear here, which drives this bevel gear, which is attached to this bevel gear, which then drives this bevel gear. So it's just a direct drive from the crank through those gears to this main shaft that runs through. And of course, we've seen that there's a crank on the other side. So kind of see down in there, there's a bevel gear on the, actually no there isn't. So this shaft actually runs all the way through back to that crank, which we saw earlier. So that whole thing works like that. Okay, so let's do a little bit better demonstration of this multiplication table. So I'm going to put this into 2, and let me just pin that up real quick. Okay, so there's like a toothpick in there, and hopefully that'll hold it at position 2. So let's go to multiply, because it won't do you any good if you try to add and set this to something other than 1. what's going to happen is it's going to add both digits to the same register position because there's no register movement. So it's just going to give you a totally invalid result if you set this to add or subtract and this is something other than 1. So if you got that set to 2, you've got this set to multiply. So what's going to happen is the first thing it's going to do is add the 10s digit. So remember, we've selected row 2 on the table here, and based on the position of this, we've selected column 9. So what we expect to happen is we're going to add 18, which is 2 times 9, in to this position of the register. So the first thing that's going to happen is we're going to add the 2. So I don't think my... Yeah, I need to pin that up better. It's not in, this table is not in the right position, so it's blocking it. Okay, I think it should work now. So I got that pinned up in the right position now, hopefully. So yeah, so we're going to start turning the crank. We'll notice that this is going to engage the 9s rack, which actually you can see those racks are all numbered. So that is the 9 rack right there. It's going to engage with the back position of the cell that we have selected. So I've selected row 2, cell 9, which has, again, 2 numbers, an 8 and a 1. Right now we're engaging with the 1. So if I keep turning the crank, it's going to push this rack 1 position forward, which will turn this gear 1 position, which will turn this gear 1 position, which would then add 1 to that position of the register. So it moved it 1. There it goes. Now, so it moves it 1 direction and then moves it back to add in. And now what's going to happen is, actually you can already see it has happened. This has moved over, and now it is engaged with the 8 of that cell. So you can see that now the 8 position, 8 digit of that cell is engaged with the 2th rack. It's going to turn this 8 positions. So you can see it added the 1 first and then the 8. And what I didn't explain in the intermediary was the carriage shift. Let's see if we can get all this in shot. So first we add the 1. Now we're shifting the carriage, but you can kind of see this shaft is moving at the same time. Now we're adding the 8 that we shifted the carriage, and we're done. So again, we add 1, the carriage will be moving at this point. Now we're adding 8, and then we're done. So it adds 1 in this position, shifts that over, then adds 8 in the next position. So it's added 18 to the register, which is 2 times 9. And that's basically how all of the digits are going to work. If we set this to, say, 7, and we set this to, say, 5, which I think that's 5, 7 times 5 is 35. So when we do that, it's going to add the 3 first, shift the carriage, then add the 5. So basically all we're doing when we move this lever and move the input sliders is we're selecting an index into this table. So this selects the row of the table, this selects the column of the table, and then each column has 2 digits, the 10s digit and the 1s digit, and then adds those sequentially to the register. So I hope that's made sense. I couldn't really think of a better way to explain it than that. Just essentially as an address, you've got your row address, your column address, and once you've selected your address, that address holds the value for row times column and adds that to the accumulator. And it works with multiple columns too, so if we set this one to like 5, we set this one to 9. So then right now we've got it set to 2. So this column is going to add 2 times 5. This column is going to add 2 times 9 simultaneously. So if you watch, when I turn the handle now, both of these are going to be adding simultaneously. This one's going to be adding 10. Well, this one is adding 18. So basically the same idea, just carried across all the columns. So each column can select its own column essentially in the table. So you can have, one row is selected for everything, but then each slider can select its own column, so you can index into different cells on the table for different columns. So again, I hope that's made sense as to how this works. Basically, it's the same way if you were doing multiplication by, memorizing a multiplication table on your memory. You memorized what each thing is, and then when you think of a number times a number, you're looking up into that memorized table what the answer is. Well, this thing does the same thing. It has its table carved out of a lump of brass, and then based on, what you set the row to and the column to, it's just looking into that table and copying the value from that table through these sliders, through the gears, into the register. So yeah, a couple of housekeeping things elsewise. This gear, which is attached to the same main shaft that does the mode, addition or subtraction mode, and the register shifting, this shaft comes down to this gear. This gear has a cam on it, which does the movement of the table from the 10 digit to the 1s digit. So let's see if I can get this all in frame. See, it moves it one way, and then as the cam goes around, and now it moves it the other way. So that selects the 10s digit first, then moves the whole table over to engage the 1s digit with the 2 thwacks. And then this lever is attached to this shaft, which has a bevel gear on it. That bevel gear drives another bevel gear here, and then there's a straight cut gear here and here, and engage with a 2 thwack on the back of the. See if I can get rid of that. It's engaged with a 2 thwack on the back of the table. So as you move this, the whole table moves up and down. And then normally this is held in place by the plate that goes on here. That plate has holes in it. So you would lift this up, move it, and then drop it into one of those holes, and that would lock it in place. But now we just kind of have to hold it like this. Yeah, and like I said, so that cam moves this shaft, which has a pin that goes in this fork, and then this fork has rods here that move the whole multiplier table back and forth. And of course, the multiplier table then is driven by these sliders here. And you can see you can move up and down in that, and then these sliders move back and forth based on the crank over here, which I think we saw before. So yeah, I think that pretty much sums up the base of the machine. Oh, one more thing. This here is for the counter. So you see it's got its bevel gears moved up above the bevel gears of all the other columns. So this is just adding the, basically whatever we're multiplying by, it adds that into the counter. So you can see this is engaged with this shaft is driven by this shaft, which is driven by a gear that's permanently engaged with the 1s rack. So no matter whatever we set this table to, this is going to always look up 1 times whatever the row we select and add that value into the counter. So if we select, 9, this is going to add 9 into the counter. If we select 5, this is going to add 5 into the counter, and this just keeps track of, what you multiplied by. Yeah, I think the next thing we can do is take a look at how the counter actually works. Okay, so I kind of laid the counter on its back. The top is actually up here now. So you can see on the bottom here, these are the bevel gears for the regular accumulator inputs, and then these are the bevel gears, or not inputs, but the accumulator gears, and these are the bevel gears for the counter. Obviously you can see that those have much finer teeth because basically they have 0 to 9 twice on them, one going in the positive direction, one going in the negative direction. So we can count subtractions as well as additions. So the counter itself is not super complicated as far as how these work. So it's going to be kind of hard to see, but you can kind of see up in there. They've got, actually you can kind of see it right there. So you can see the little flowery things there. So it's got the same type of, flowery type digit wheels that the decomer arithmometer has, and it's got spring-loaded detents. So as you turn this, it's just snapping between those indents in the gear there, which is going to be kind of hard to to see, but yeah, I probably should have showed that before I put this piece in. This piece is the carries thing, and this is kind of an interesting way of doing the carries, because this is unlike pretty much any machine that I'm aware of. Normally the carries are on the base of the machine, and then as the carriage slides, you know, back and forth, the counterparts don't move. But on these ones, the counterparts are actually built into the register, or the counter rather. And this drum actually goes in. You can see it's got a cutout here and here. Those are the bearings for this drum. So this drum is going to go in something like that, or something like that if I was showing it correctly. And spin like that. And that is driven by this shaft, which runs through the drum and is held to the drum with this key. So I can show that all in operation once I get the carriage back in. But while it's out, I wanted to show sort of how the carries actually work. So this whole thing, I'm sure you're going to be able to see, but this whole thing basically moves up and down. It's not the easiest thing to move by hand, but you kind of get the idea. So when it moves up, it engages with these little pins. You can see the pin there, pin there, pin there. When it moves up, it engages with those, and those act as sort of overshoot detents for the carry trips. So these pieces right here are the carry trips. So whenever a wheel goes from 0 to 9 or 9 to 0, which is the direction, you can kind of see how it's now tripped that. So I just move this wheel one position. It's kind of tripped that. And then that pin, you can kind of see right there, has now dropped into that hole, preventing this piece from overshooting more than it should. And that's important for the next step, because once the actual adding is done, this whole piece drops down. And now you'll notice that this tripped carry thing here, the end of it is actually engaging with a gear on the next position of the register. So that's where this drum comes into play. You can see it's got these little beveled things on here, beveled cams. So as this spins around, what's going to happen is it's going to contact this pin that's going to push it. And notice when it pushes it, it's going to move this digit here one more position. And you'll see because it must have had it in subtraction mode, so when it moved that, it also tripped this one. And because this is a ripple carry, you can see on the drum they're going in a helix. So then this one would then get tripped, which will then trip this one. That gets tripped, and of course that's the last one, so it rings the bell. And then after this drum has finished getting through all of these carry cams, or whatever you want to call them, then these reset cams hit all of the things and push them all back. Oops, that was too far. Push them all back. Actually, I guess this would have to move up first. So it's no longer an engagement with those gears. So it wasn't showing anything. This would have to move up first, so it's no longer engagement with any of those gears, and then it would reset everything. Like that. Yeah, so I think that's mostly about it for the carriage for now. Like I said, I'll show more once I get this drum back in. But basically, that's how it works. You've got your bevel gears here, drive the bevel gears here, and then as those bevel gears do their carries, they trip these things, which then engage with the gears. And then the whole thing goes back up. Not sure why some of these don't want to reset all the way, but might be a problem for another day. could be that this resets when it's halfway up. Yeah, like I said, I'll see once I get the whole thing back together, and we'll see if it works. But yeah, so also these have a detent right here, so you can kind of see as I move that detent, detents also, and then that pin that comes in from the top is just to prevent overshoot, because this has to stop exactly like this, so that when it drops down, it's engaged and ready to push that one position. If that overshoot protection wasn't there, and the force of the carry had pushed this all the way over, then when it drops down, then there's no further that it can go, so no carry would happen. So that pin that goes into these holes is just for overshoot protection, to make sure that the carry trip stops exactly here, so that it can then be pushed and it actually affect the carry when the cam comes around by moving it one more position. Yeah, then these are the springs for the detents on there, and then on the top, if I can stand this up, we got these springs here, which are the detents for those pins, and yeah, some of them I don't have them tightened down all the way, but yeah. As far as the clearing, it's again pretty similar to how the arithmometer works. Also, you can kind of see what there's a toothed rack right there, and that toothed rack engages with a gear on each wheel, which has one pin missing at the 0 position. So when you clear it, let's see if I can. So when you clear it, also you can see that one turning there. The toothed rack drives the gear until it gets to 0, and when it gets to 0, that's where the tooth is missing on that gear further up the shaft, so it doesn't get any more drive and stops at 0. So pretty simple clearing mechanism there. The counter is the same way. Has another, you can see the tooth rack there protruding for the counter. Basically the same idea. There is a gear that has one tooth missing at 0, and then the rack drives the gear until it gets to the missing tooth, at which point there's no more drive, so it stops at 0. Yeah, so I think that pretty much covers everything I need to show with the machine still disassembled, or at least with the carriage out. Also, these are the wheels here, so the carriage rides on these wheels. And then this piece is what engages with this cam here. So each of these rollers here, one roller goes in the middle, one roller goes on this side, and one roller goes on that side. So there's 3 rollers engaged with this spiral cam at all times. And then as this rotates, it's going to push this along via that spiral cam. And then of course this is attached to the register. It pivots here and here. And then this little thing here goes into this. So when you push for the register release, basically that rocks this whole piece and lifts these rollers out of engagement with this cam. So then you can manually move the carriage back and forth. And then the carriage rollers, they roll on here, that cutout in there, that cutout in there, and then there's another metal piece that goes from here to here, and then the top rollers roll against that. Yeah, so I think the next step is for me to get the register back together and put it back in here, and then we'll show the actual operation of the whole thing. Okay, so hopefully you should have a pretty good idea now of how the base machine works. So with the carriage installed, those bevel gears are completely hidden. You can't see them at all. They're under the carriage down there. I've got the drum installed in the front here. You can just kind of see in there the tails of those carry tabs are in there. So we can do a little demonstration of how those work. I'll just put this on add mode. And actually, let me get something to prop up the multiplier table again. Okay, so I got the multiplier propped up to the 5 position. I think it should be the 5 position anyway. And so if I turn the crank once, this number, which right now I have 625 set on these sliders here, if I turn the crank once, we should see 5 appear in the counter, hopefully. Yes, we do see 5 there. So, okay. So, and you can see it's added in, basically it's not, of course, not the right number, because basically this has done Well, it basically did the tens digit and the ones digit in the same column, so you're not getting the right answer. But just for demonstration purposes, we can see the carry tabs. As I turn the crank a couple of times, you'll see no carries happen yet. There one happens. So see how this tab is pushed over because the carry's happening? And then it gets reset at the end. You can kind of see how that works. So when a carry happens, see if I can go a little bit slower and actually catch it in. Nothing happened that time. Okay, see? So see how that tab got pushed over right there? So now it's going to contact this little ramp here, which is going to push it over some more, and that's actually affecting the carry. And see it, that carry caused another carry. So that both those columns carry, and at the end, it resets. So that's basically how that works. And I'm not sure if I mentioned it, but there's a little tab on each of these wheels. So when the wheel goes from 1 to 9, the little tab hits another tab on those things and sets them in the carry position. So looking at the front here, you can also see them moving, maybe. A little bit dark down there, but nothing happened that time. See how that one tripped over? I guess we said at the end. So that's basically how those carries work. You can see them in action there. I hope that made sense. I tried to explain them the best that I could. So anyway, let's do an actual multiplication. So we'll clear out everything here. We have to shift this over one position for a one-digit multiplication. We'll set this to, let's just set it to 25 for demonstration purposes. And we've got our multiplier there set to 5. We'll set this to multiply mode. As you can see, this drum has now engaged with the tabs here. And we're still in add mode according to the mode select cams there. So now what's going to happen is it's going to do, so this is 2 times 5, which is 10, so it's going to add 10 in this column. And then, and then 5 times 5 is 25, so it's going to add 2 in this column. And then it's going to shift over, and then, again, 1 times 5 is 10, so it adds nothing in, after it shifts over, it'll be in this column. And then 5 times 5 is 25, so it's going to add 5 in this column. So we should end up with is 125. The 10 plus the 25, or I should say the 100 plus the 25, because this is shifted over. So let me see if I can get this decently in frame here. And we'll turn the crank. I think you can see everything. So as you saw, it did the tens digit in each column and then the ones digit in each column. We can do it again. I should probably do a little bit slower. I'll try doing it a little bit slower. So first it does the tens digit. So it did the 1 times 5 is 10, so it did that tens digit, which is a 1. 5 times 5 is 25, so it did that tens digit, which is a 2. Then it shifts over, resets, and then now it's going to do the ones digit, which 1 times 5 is 10, so there is no ones digit. 5 times 5 is 25, so there's a ones digit of 5. And that's how it works. Yeah, so I think that's pretty much it. I think I covered most of the other stuff in the actual part of the video where I had the carriage out. One thing I did forget to mention, if you remember, this piece goes up and down. So let me change this to add mode. And if I turn the crank again, you'll watch that. See how it goes up, then it drops down. So that is controlled by cams, which you can see are inside these discs here. And riding on those cams are these levers here. So you can see this piece here has a pivot back there, comes up and has a cam follower that goes inside that cam, and then has a little cup here that hooks onto this screw, which is attached to the carry trip holder, whatever you want to call that. So this whole piece will rock, and as it rocks, it controls the movement of that carry chip holder thing, whatever you want to call that. So you can see that moving there. So that's basically how that works. Yeah, and then this drum is driven, you can see there's a key slot in this shaft here. This shaft is driven by this gear. You can see there's a timing mark there, so that has to be timed so that the carries happen at the right time. And there's also, so you can see down in there, there's a 0. Yeah, you can see there's a 0 stamped on the drum, and there's one on each side. So that times the drum, so that 0 with the line there is straight up and down when the crank is at its home position. So basically everything is timed in this machine. There's nice timing marks. You can kind of see there's timing marks there too. And there's a timing dot on each of those. So yeah, everything's pretty well marked as far as timing goes, which is nice. Sometimes machines are not marked, and then when you take it apart, you don't realize that everything has to be timed a certain way, which is inconvenient, but this one's marked pretty well. And there's also a lot of hand fitting going on here. I'm not sure if you can see, but each of these square shafts has a number on it. So those will all, I guess, hand fit to their position. Each of these has a number on it, so I guess those will all hand fit to their position. Even each of these carry trip rockers down in there has a number on it. I don't think you'll be able to see it from here. I think it's on the bottom side, but yeah, those are all numbered 1 to 15. So I don't know how long it took to make one of these machines, but it must have taken quite a while with all that hand fitting. And all over the machine, it's stamped with the last 2 digits of the serial number. So like this is stamped, that's stamped. Almost everything is stamped. You can see that is stamped right there. Kind of hard to see, but yeah, almost anything you look at, not every single piece, but pretty much all the pieces. You can see there's a stamp right there on that gear. There's a stamp on the cam also. Even these input sliders, each of these input sliders has a number stamped on the bottom of it, and that number is correlated to, so I can move some of my stuff out of the way without knocking things over. That number is correlated to a number which is stamped on each fork. So each fork is correlated to each input slider, which is interesting. And of course this piece goes in here, and this piece goes there for your multiplier. So yeah, I think that's pretty much everything I wanted to show. I'll probably put this piece back on, and then we can do a multi-digit multiplication. But yeah, I don't really think there's anything else I really need to show, because I think I explained pretty much everything when I had it apart, and then now it's just, you know, showing it working all together, which you did see. So yeah, let me put that back on, and we can do a multi-digit multiplication. Okay, so I've got that plate back installed, so let's move this out 2 places, and we can do 625. So I'll just move this slider down to rack 6. So that'd be 6, should be 625. And then we can also multiply by 625. So I'll set this to 6. We'll set this to multiply. Now we should be able to do the first digit. And so we got a 6 there. So now we want to do 2. And then we want to do 5. And the bell rings when the carriage gets to the end. That's done by this little finger here trips this little bell catch there. And so there we go. We've got our 625 there. So 625 times 625 is 390,625. Unfortunately, some of the silver plating has come off on some of these digits. I did clean them up and lacquer them, so it should protect them. But unfortunately, over the years, I guess dirt, must have got in these holes here and sort of ground away some of the silver plating on number 0. But it is, for the most part, still readable. So Yeah, anyway. That works. For division on this machine, you have to use the lookup table, so we're not going to do that right now. We can do a subtraction, just for fun. Let's do an overflow subtraction, so I'll set this to rack 1, set this to 1. So now we should have 0 minus 1, which of course is going to cause an overflow. And it's interesting the way they've built this machine, because when you get an overflow, all of the carries trip, so it just ripples all the way across. And then of course the carries happen sequentially, but all these reset cams are all in a line. So when the crank gets back to the home position, all these cams are trying to reset all of the carry chips at the same time, and it almost feels like the whole machine's jammed because it just takes so much force to reset that. I haven't put any grease on those yet, so I'm going to put some grease on each of those cams and see if that makes a difference. But yeah, so actually you can watch this happen, maybe. So the first one trips, and you notice that it tripped in to the right. When I was adding, it tripped to the left, but because we're subtracting, it tripped to the right. And you notice that they're tripping all the way across. And also overflow, it rings the bell. And now, all of them, all at the same time, are going to contact these reset ramps, which really makes for a stiff part of the crank turn. So, yeah, that's kind of interesting. Usually, like on the other machines, the carries reset, the carry chips reset as part of the carry, but on this one, they all reset at the same time, and it makes for a bit of a stiff part of the crank turn there. But yeah, you can see it carried all the way across. So if we now change it to add mode, it should do the same thing. So now when you watch, all the carry chips will trip the other direction. So that's the first crank for the 10 digit, which there is none. Now they're going to start. So now it tripped to the left side before it was tripping to the right side. And they're going to trip all the way across. And then we have the stiff reset part, and we're done. So yeah, I hope that gives a pretty good overview of how exactly the Millionaire Calculator Mechanism works. Obviously the heart of it is the multiplier table under there, and then like I said, it's just a lookup. These look up a column, this looks up a row, and basically it selects a value based on row and column to add to the accumulator. So in principle it's pretty simple, but it's a pretty interesting mechanism. This machine is very big. It's very hard to get everything in camera, so there's probably quite a few parts of this video where something was out of frame, so I apologize for that. But it's hard for me to think about what I'm saying, think about what I'm trying to say, and pay attention to where I'm pointing the camera at the same time. So, and it's even harder on a big machine like this. Like, I almost have to hold the camera over my head just to get this whole thing in frame. But anyway, I hope that made sense as to how this very interesting calculator works. So I hope you enjoyed this video, and thank you for watching.